All right, everyone. Welcome to the Flash Loan Masterclass. We're going to go ahead and get started here. Let some people trickle in. But as we're getting started here, let me know if you can hear my microphone in the chat. And let me know where you're watching from. All right, so while everyone's doing that, we'll waste no time. I'll go ahead and kick us off. Everybody, welcome to the Flash Loan Masterclass. I'm super excited to show you how to borrow millions of dollars in cryptocurrency for free so that you can use it in the blockchain development, use it for trading. You can use it for arbitrage, all different kinds of stuff that we're going to talk about tonight. We're going to learn about what flash loans are, how they work, and how you can use one specifically tonight for trading. So a couple quick house rules. I want to make sure that we have a few different chats. Some people might be in the cohort. Some people might be in Blockchain Mastery University. Let's try to keep all of the chats in the YouTube chat here. It's the only way I can kind of watch out for all the questions. We will have a time for questions at the end. I won't be able to watch the chat completely while I'm presenting here. So just a quick note on that. And then finally, we're going to implement the entire code for a flash loan trading app today. We won't have time to code everything step by step. So I am going to go over all the code for you, show you how to edit it, how you can apply it to different applications and stuff like that. If you do want to learn how to code flash loans from scratch, build your own applications with this type of stuff, really customize your own strategy, well, the absolute best way to learn those coding skills is going to be through hands-on mentorship. So I'm going to put a link down in the description below. We do have a couple slots open here. So if you want to work directly with me, Gregory, and the rest of the DApp University team to learn to become a blockchain developer step by step over the next several months, we do have a couple slots open up. I did this boot camp years ago, so I could certainly attest to it. And we probably have some members from the cohorts here that can attest to that as well. So great way to take advantage of the current market so that you could build with your own flash loan applications, break into the blockchain industry. In times like these, I think it's important not to look at the numbers, right? Don't look at the market. Definitely good to head down, learn some development. The people who focus on building and focus on getting an education are going to win right now. So I'll put a link to that in the description below. But let's waste no time. Let's kick us right off. All right, so let's start off with the basics. What is a flash loan? So flash loans are essentially where you could borrow millions of dollars of cryptocurrency for free, right? So long as you pay it back in the same transaction. All right. And you might think like, what the heck does that mean, right? So basically with blockchain, you can have simple transactions and complex transactions. A simple transaction might say like, hey, I'm going to essentially send cryptocurrency from my account to yours. That would basically just say, hey, take this crypto out of my account, put it in yours. A complex transaction might have multiple steps, like borrow money, do something with it, pay it back, and then you could keep the profit if everything went successful, right? So flash loans happen instantly on the blockchain. They're completely free. You don't need any money to do this. There's no collateral, right? There's no money down, okay? And basically, you could do this all different type of activities, but what we're going to specifically focus on tonight is going to be for trading, and we're going to see that here in a minute. So basically, a flash loan provider comes from a smart contract, right? And the smart contract in particular that we're going to be looking at are liquidity pools. So if you see different DeFi applications out there, they have all these different reservoirs of money like USDC, Wrapped Ether, DAI. If you look at a website like Uniswap, for example, it's powered by liquidity pools. So you might think like, hey, where does that money even come from, right? So whenever you're trading on Uniswap, basically there's a feature where people can park their money in the application, earn a yield, so that the application has money to trade, similar to how banks work and stuff like that. But they're getting a passive income by just letting it sit in the app. So you can take the money that's not being used in these liquid pools and do what's called a flash loan. So you could flash loan it out to do different things. You might see this done for different things. And basically, you can have a DeFi app that speaks to a liquidity pool, and then you could create your own arbitrage bots. There's a lot of different things that you could do here: yield farming, liquidation, and you can also do leverage trading, which is what we're going to talk about tonight. So side note, arbitrage, we could talk about a little bit. If you've seen some of the previous Trading Bot Masterclass series, that's usually what we do with flash loans, where basically you buying cryptocurrency on one exchange and then selling it on another exchange for a small profit. So if you could do that for $100 on one exchange, sell it for 101 on another, it's $1 profit, right? Now you could do that with a lot of different cryptocurrency, and that profit would add up. Or you could do it over and over again, all right? So specifically what we're going to be talking about tonight is how not to do arbitrage, but how to trade cryptocurrency that you don't currently have. So let me explain what I mean by that, right? So you're going to need some initial capital and some cryptocurrency in order to do this. But you can also trade with cryptocurrency that you don't have. And what I mean by that is, let's say you went to an exchange. All right, so let's take a look at Uniswap, right? Uniswap is a decentralized cryptocurrency exchange where you can connect your wallet and basically buy lots of cryptocurrency. And if you have USDC and you want to buy, let's say like maybe maybe you have like $1,000, or whoopsie, wrong here. Maybe you have like $1,000, right? You want to see how much ETH you could buy, or you wouldn't be able to get that much. Or let's see how much one ETH would be. All right, so one ETH is about 1958. So let's say, right, you had 19,000, around 19,000. You'd be able to get about one Ether, right? So you have 19,000 in your wallet, you'd be able to get one wrapped Ether. Now, what if you wanted to get like 3 wrapped Ether with just your initial capital of the 1,900? Or what if you wanted to take just $1,000 and buy an entire Ether around, it's around $2,000. You would do this maybe if you were bullish on Ether. You think Ether's going up, maybe you saw some good news, right? Well, you can actually do that with the strategy that we're going to show you tonight in this video. So that's basically using flash loans to take out leverage for trading, all right? I do want to be crystal clear on 2 things here. So the first one, leverage. It's not something new. It's not a new concept to do this with flash loans. Not a new concept with DeFi or anything like that. Leverage is where you could basically borrow money to trade, mix it with your own money. And this has been around for a very long time, right? All right, so that's the first thing. Second thing, there are risks associated with this, right? While flash loans cost nothing to use, there is risk with leverage. So, and I'm going to spell that out for you. So anytime you borrow money, if you did this and the price maybe goes down too much, or you're at this point at risk of getting what's called liquidated. So you have to know that going into this. It's definitely a risk. I'm going to make these risks clear as we're going over the code and quantify it, so that when we look at these strategies later, it's understandable. So, but this is an awesome way to use flash loans to maximize your upside whenever you're doing a trade like this. So that's actually what's called going long. Basically, if you were to say, I'm going to take, 1,000 USDC here, and I'm actually going to borrow 2,000 USDC to make this 3,000. You can actually buy 1.5 Ether, right? If we flash loan 2,000, we'd essentially be able to buy 1.5 Ether. So, and then, if we were to do that, and maybe let's say the price of ETH doubled or something like that, well, then you would have essentially $6,000 worth of ETH, and you would get a ton more profit. So that's what trading with leverage looks like. That's just a quick example. I'll show you that when we look at our application here in a minute. But we got cover a couple of other concepts before I get into that. So let's talk about ERC20 tokens. Okay. The blockchain that we're going to use tonight is the Ethereum network. This strategy can be applied to other networks, which is really cool, not just Ethereum. Basically, all the cryptocurrencies that we're going to look at are going to exist on the same network, the Ethereum network. And then we're going to, just because we did this in Solidity, it means they're EVM compatible. So it's any EVM compatible chain, this strategy will work for, because they use ERC20 tokens. So an EVM compatible chain will be able to use this code that we're going to write. And if you make, I'll show you where you're going to make some small tweaks, but that is the power that Solidity gives us. Solidity is awesome because if you write your code with it, again, any VM compatible chain will be able to use this. You'll be able to do cross-chain stuff, multi-chain, do a multi-chain deployment. So as long as you follow the Ethereum standard, that's, there's links that I'm going to provide you guys to check out the documentation if you want to know what it is. Basically, to follow the ERC20 standard, you just need, a name. You got to have some similar functions here. You need to have a certain amount of decimal places. To comply with the standard here. So just to be clear again, the only cryptocurrencies that we're going to talk about tonight are going to be ERC20 tokens. So this just means that, like I said, it needs to have a name, symbol, token. If you want to browse the spec, and learn more about this, it's going to be provided for you guys here. So let's look at a few other things here. Let's talk about Aave. Aave is going to be a key part of our application tonight. This is essentially going to be our venue for trading and lending, and you'll see why here in a second. So basically, Aave is a decentralized saving and lending platform. It kind of works like a bank. All right. So you connect your wallet, you go here, and you have all these different types of cryptocurrencies. Opt out of that. You have all these different type of cryptocurrencies, right? Kind of works like a bank. And you essentially can connect your wallet here. We see we got Ethereum, we got USDT, it's Tether stablecoin. So you have access to all these different types of coins here, wrapped Bitcoin, some Coinbase tokens, right? So, and what you could do is deposit some cryptocurrency that you have, earn some interest, and at the same time, you can borrow cryptocurrency on the other side. You pay a fee for doing this, but this is where the power of the application is going to come in, and we'll see that here in a second. So you might know, also important not to glance over, you have to deposit cryptocurrency in order to borrow cryptocurrency from Aave. So you can't, borrow without providing some collateral, and you can't borrow the token that you provided as collateral. So you might be like, hey, I'm bullish on Ether, so I want to hold some, and you have a bunch of it anyway. So you might want to maybe supply some Ether to Aave, earn some interest on it, and then maybe borrow USDC against it with the flash loan. So you might be like, hey, I think Ether is going to appreciate, so I want to supply it, and then I'm going to borrow against it. So there's a bunch of different strategies that you could do, but this is kind of be our venue to help us provide leverage later. So you have to understand how Aave works. It supports ERC20 tokens. You have to understand how Uniswap works, right? This is where we're going to be trading our tokens. Uniswap, basically, it's like you just choose a token that you want, choose the other token, connect your wallet, click swap, and then you're done, right? The last piece of the puzzle here, the last thing we're going to look at is Balancer. Balancer is our flash loan provider. It's a liquidity pool, right, that I mentioned earlier. They have a decentralized cryptocurrency exchange built with it. So Balancer is pretty cool. It has a lot of awesome features. I like Balancer for a lot of different stuff, mainly because it's EVM compatible, meaning you could use it across a bunch of different chains. Multi-chain, right? As I just said, you can deploy it to multiple different blockchains. Very easy to implement your code. I'm on this page for a reason. This is kind of really all you need in your code. You just, copy this. It's a template that you can bring right into your code. We're going to look at this more in a little bit, but the documentation is awesome. I would go through this on your own because it's short and simple and really readable here. It has 0 fees, right? So you don't have to pay any special fees to use Balancer. So you need to understand Balancer. We need to understand Aave, and we need to understand Uniswap, right? These are our main resources for the application that we're going to be using tonight. So with that out of the way, let's talk about how some of this with leverage might work. So essentially what we're going to be doing tonight is we're going to be doing a leverage long first. We're going to talk about short, but we're going to do a long first without a flash loan. So how does that work, right? So let's look at a scenario here where, just for math, we're going to do 1 week equals 2,000 USDC, right? So let's take leverage out of the equation first, and let's just look at this. So let's say you bought 1 Ether, right? It's around 2,000 like I just said, the price goes from 2,000 to 4,000. You sold it without any leverage. Your profit obviously would be $2,000, right? Let's say you started with 2,000. It's now worth 4,000. You made 2,000, right? That's a 100% return. The asset did a 2x. So you doubled your money essentially, right? If you were to do it with a flash loan. Now, if we introduce leverage into this, let's say one WETH again is worth 2,000. What we could do is we could supply that WETH to Aave and then borrow 1,000 USDC against that, swap it on Uniswap for more WETH. And now instead of holding one WETH, we're actually holding 1.5 WETH worth of exposure. All right. Let's just say WETH goes from 2,000 to 4,000. Like I just said, your 1.5 WETH is now going to be worth 6,000, right? You repay the $1,000 that you borrowed. You repay your collateral, right? That leaves you with 5,000. You started with 2,000. You have a $3,000 profit instead of the $2,000 profit. That's leverage. You increase your exposure, so you increase your gains. Now, important, you don't need a flash loan to do this, right? You could just manually supply, borrow, swap, and you create a leverage. But what if you want to go bigger and do it all in one transaction? Well, that's where flash loans come in, right? So again, let's say you started with 2,000, you flash loan the 2,000, you swap 4,000 for 2 ETH. You temporarily have 4,000 USDC when you do this. So you swap the 4,000 for the 2 ETH. You supply 2 ETH to Aave. You borrow 2,000 USDC against it. And then you use that 2,000 USDC to close, to repay the flash loan, right? So this all happens in one transaction. You are now in an open position. So by the end of the transaction, the flash loan's already paid back. So this is really important. What are you left with? You have 2 ETH supply as collateral, and you have a 2,000 debt on Aave. That's 2x leverage created instantly. Notice without the flash loan, we only borrowed half the value. So this model is pretty realistic to real LTV constraints. The flash loan lets us construct a larger leverage position instantly. It's awesome. Let's look at the other direction. Because you can also do what's called going short. So let's say you think the price of Ether is going to go down. Without the flash loan, here's what you could do. You could supply 2,000 USDC to Aave. You borrow 0.5 WETH. You swap 0.5 WETH for USDC. At this price, right, if we're using the same numbers, that's worth around 1,000. You immediately swap the 0.5 WETH for 1,000 USDC. What's your position at this point? You supply 2,000. You now have 3,000 in total. You still owe 0.5 WETH. So if ETH drops 2,000 to 1,000, that 0.5 WETH that you now owe only costs 500 to buy back. You buy back for 500. You repay your loan, and you're left with 2,500. You started with 2,000, right? So you made 500 because the price went down. That's what a short is. You borrow an asset, sell it immediately, and buy it back later for cheaper. Let's do the same thing now with the flash loan. So let's say that you start with 1 ETH, you flash loan 1 ETH. Now inside that same transaction, you temporarily, right, have 2 ETH. You swap the 2 ETH for 4,000 USDC. Take the 4,000 USDC, bring it to Aave, right? We're going to borrow 1 ETH. So we supply the collateral, right? And now we can borrow 1 ETH. And then we're going to pay that 1 ETH back to repay the flash loan. This happens all in one transaction. So by the end of it, the flash loan is already paid back. What you're going to be left with is 4,000 USDC supplied as collateral. We're going to have 1 ETH in debt. And that's what a leverage short position is essentially, right? This is a leverage short position. We created it instantly. If ETH drops, that 1 ETH becomes cheaper to buy back. And that's where the profit comes from. So that's what we're going to do in our code tonight, right? In our coding example, we're essentially going to go long and we're going to go short. So using flash loans. So those are the major players to understand how Aave works. This is going to be where we get our lending and we supply to Uniswap for swapping our tokens super quick, and Balancer to provide our flash loans. All right, so I'm going to go ahead to the GitHub repository. You will not have access to this, but let's go ahead and start getting set up here. So you won't have access to this GitHub repository, right? There's going to be a link in the description for the code. There's going to be a zip file to download, and you can download that zip file. You could follow along. You certainly don't have to. There's going to be a recording, and you can take a look at this tomorrow too. So, but you're going to want to go ahead and unzip that code and open it up in your terminal. Gonna get my text editor here. Okay, so I have this opened up in my text editor here. I'm using VS Code. You can use whatever you like. Some people like Sublime. I like VS Code a lot. I have some awesome extensions. Also, if you guys want to use some of the extensions that I use, right? Prettier, Solidity by Juan, Tailwind's always good, NPM IntelliSense, HTML, GitHub pull request. You can always pause the video. ESLint, ES7, this is for React, WSL, Beautify, they all do the same thing, kind of. Just some people always ask about the extensions, gives you all these nice colors. Let's go ahead and get started here. So again, you won't have access to the repo, but you can unzip it, open it from the terminal. To check your node version, it's one of the most important things to do first. You could just do node-v. If you're not using node, if you're not using version 24, you're going to switch to that super quick because you're going to get a few errors if you don't have this version of node. NVM is node version manager. You can just do NVM install 24. This will install node version 24. After it installs, do NVM use 24. This will now set your node version properly here. So, and if you need the installation for Node or anything like that, well, again, all of the documentation is going to be provided. So you just go to Node, download it, go to NVM, download it here. All right. So once you do that, you could go ahead and you could copy the command I'm doing here, cd /loan masterclass. Going to jump back into my text editor. I'm already CD'd into it. So, nothing's going to happen. So I'm already in it. So make sure you're CD'd in. If you run your commands and you're not in the root folder, it's going to make things get weird. So once you're inside of here, first things first, always install your dependencies. So do npm install. I, again, already installed mine, so I'm not going to go ahead and do that again. It might take a second once everything's and you might get a slew of messages. It's okay as long as it's not a red error message. You should be fine. Yellow warning messages are a-okay. Another major piece of the puzzle before I get too far ahead of myself is that you're going to need an Alchemy account. So this is what Alchemy is. It's a Web3 infrastructure. So we're not going to need access to we're going to need access to a blockchain node, but you don't have to run your own node. You might be familiar with Infura from other tutorials, or maybe you did one of my tutorials and you did Alchemy, right? So sign into Alchemy. I'm not going to sign in because I already went through it. So go through the sign up flow, right? And then what you're going to do is create an application. And then once you click on the application, you should see something like this, right? There's going to be a URL, right? It says Ethereum mainnet. You could just go ahead and hit the copy button right here. We're going to be using Ethereum mainnet, not the single API key, the whole link here, okay? So we're going to copy this URL, paste it somewhere, keep it handy because we're going to use it in a second here. But this is going to help us for testing purposes because we're going to actually do what's called forking the mainnet. So we're going to fork the mainnet, use real world values without having to spend any money. It's awesome for testing. It's going to give us a nice sandbox environment. So, so just, keep that on hand. Let's get the text editor back up. All right. So install your dependencies, right? And I just want to be clear about something. So you can use it because I know that people are going to have questions about this. You can use this strategy for high frequency trading if you want to, and you can actually perform it on the real blockchain. Again, we're going to do it in what's called a sandbox environment. What does that mean? You don't need to have any cryptocurrency to do this. This is all going to be testing, making sure it works before we bring it to something like the mainnet. So, and that's what I recommend for everyone. I would always fork the mainnet for your blockchain development, but before actually going to the real mainnet, right? So, this project, right, we're going to use Alchemy as our connection to the blockchain here. We're going to use something called Hard Hat. And this allows us to test against a real blockchain. We're going to use our Alchemy API key to talk to the blockchain. And what hard hat lets us do, hard hat lets you deploy all your stuff across many networks, do amazing testing. I love hard hat. But what it's going to do for us tonight is it's actually going to allow us to freeze the blockchain at a certain block, right? And then we're going to actually be able to run a few commands, do a little bit of market manipulation to change the prices of stuff on the exchange. We're not actually manipulating the market, right? Because we're going to be running a local dev environment here. But we can connect our project to it, have a test blockchain, manipulate the market a little bit to make sure that our code is going to run as expected when a big market event actually does happen, and you're prepared to run your code. You don't want to be like, oh, I'm wondering if this is going to work or not. ETH is flying up and down. I'm trying to make something happen. You don't want to be waiting for that to happen to test it. You can manually make that happen with what's called an impersonator account. I'm going to get into all of that once we get to the code. But you definitely want to test this stuff on your computer in a sandbox environment before you start swinging any real money at it, right? So just going to go ahead and issue that disclaimer here. One more thing, this code is not fully audited, right? So this is not production ready code. If you were to take this code that I'm showing you tonight, trading with leverage is certainly a risky endeavor. So if you take these smart contracts and use them in production, you're certainly assuming all risk for that. I have to say that I'm going to show you guys how to do this stuff on your computer today, though, how to practice this, how to develop your own strategies. But if you take this code, bring it to production, you're assuming all risk for doing that, right? So I'm just going to drill that in. But never fear, right? So if you want to learn about it, how it works, increase your skills, we're going to be able to do this on a local blockchain tonight. And that's exactly what we're going to do with the Alchemy API. So let's go ahead, jump back to GitHub so we can look at our instructions. After you run npm install here, you're going to go ahead and run this command here, npx hard hat key store set alchemy developer rpc url --dev. Basically, and that's basically what happens here, and this is all caps, the alchemy developer rpc. I've already done this part, so you could go ahead, bring this to your terminal, go ahead, paste this here. Nothing's going to happen for me if I do it because I've already done it. So if you want to, so after you paste that, sorry about that. After you paste that, it's going to go ahead and prompt you to with the question, right? You're going to go ahead and take that Alchemy API key that you got and paste that right in, and then it's going to go ahead and save it, right? So if you already have one, you got the same command, you want to see what your API key is, you could do npx hard hat key store get, right? Go ahead and paste that right in. It's going to show you what your API key is. I'm not going to run that because I don't want to show you guys my API key, but you can go ahead and confirm it's what you expect. All right, so you want to do key store set, key store get. The --dev flag just keeps you from having to essentially put in your password all the time. If you want to see the full documentation for that, you definitely may. We're going to link everything down below.
Hey, Anthony, real quick, buddy. I don't think anybody can see your terminal.
Oh, they can't?
No.
1 second. Thanks for letting me know.
Yeah, of course.
All right, sorry about that, guys. Yep. So
yeah, there's your text editor. Awesome. Cool. Back to the show.
Gregory's lurking in cyberspace, guys.
That's right. All right. See you guys.
All right, so and I might just ditch I might make myself a little bit smaller here, just so you guys can see the terminal better. All right, sweet. So we're back to rolling here. All right, so go ahead, paste in your Alchemy API key here. You can use whatever text editor you like again. So we're going to go ahead and we're going to go through all of these code here. We're going to go look at all these files. I'm going to go through each one, right? So you're not going to be left hanging here. The first thing I think we should go look at here is our hard hat config file. This is where we set up everything for hard hat. all of our important information, like what compiler version we're going to use, what networks we're going to be using here. This is where we specify the block number that we're going to be looking at when we fork the main net here. So hard hat is awesome because you could deploy it to any network. Like I said, you could fork the main net. We have our hard hat Alchemy developer RPC URL that we just saved. It's being used here for the forking, right? So that's why we set that up. Let me get to this picture here. All right, so for the scenario tonight, what we're going to do is we're going to create a simulation environment like I talked about, right? We're going to freeze the blockchain in time. We're going to freeze that at that specific block number, right? So that block is September 3rd, 2025. If I jump back to it real quick. Just going to copy that. And if you wanted to do, freeze the blockchain at a certain date and you want to, maybe there's like a specific event that happened or something like that, you could go over Etherscan. They have block date converter, and you could just like go ahead and paste in the date or go to a certain date and it will convert it for you. You could bring it right into your code. So that's exactly how I did that. And you could do it too if there was a specific date you want to look at. All right, so let's jump back to the text editor. And I think what we're going to do now is first, let's just go ahead and run our tests. That's a good indication that our application is working as intended here. So if you want to go ahead, you unzipped everything to run your test real quick. You just do npx hard hat test -- network hard hat mainnet. This is going to run it against our forked mainnet here. So I'm going to go ahead and paste that right in. Let me make the terminal a little bit bigger so we can see what happened here. So it ran all of our tests. I'm going to go over the test file so you can see it 100%. Oh, sorry. There you go. So I'm going to go ahead. I paste that right in. npx hard hat test -- network hard hat mainnet. Went ahead and ran all these tests. Again, we'll go through this, but this is a good indication of the app's working. So you could do it yourself just to make sure. We have a test in here, right? We're testing a few different things. We're testing our flash loans. We're testing a long and short position here, making sure everything works. And if you were to maybe do this as a trading bot or do it on your own trading scripts, maybe you're doing high frequency trading or swing trades or something like that. Maybe it's a longer term swing trade. You would probably break out the test, or if not the exact test that I'm going to show you here tonight. And I would, going forward, I would make individual scripts that you can run manually from your computer. If you like algorithmic trading, of course, you could take these functions that we're going to show you here today and test them, bring them into high frequency trading. Do some algorithmic type of stuff, right? So you can watch some of our other videos, right, in the vault, combine pieces of the tech. We have a few videos with X402 payments and MCP servers with Claude. You can get into AI agents here, have them watch the market or something like that, execute commands, right? We're not going to go over that tonight, but I know some of you might want to go down that rabbit hole after you watch this video, and I think that's completely reasonable to, want to put everything together. So let's look at our test here. What happened? Successfully flash loans 1,000 USDC. The Ether price before, this is our initial capital 1,000. The price before was 4,477. This health factor here, we'll get into that. Just the higher above 1 you are, the better. If you get close to 1 or 0, it's not good. You getting close to liquidation. The price after, it did all the swaps and everything. Nice. So the price went down a little bit in the health factor, and then there you go. That's how much USDC you would have made, after the fact here. So you might be wondering, how do we get this test to work? Because if you're doing leverage trading, and we froze the blockchain, how does the price move? Right? We've frozen the blockchain essentially. How does that work? So essentially what we're doing here is we're taking a large wallet and we are on the blockchain because we have this hard hat test environment, and we have the power that we can unlock any account that we want to. So essentially what we're doing is unlocking a whale wallet. All right. We're actually in our scripts, right? There's going to be an impersonator account. Oh, which guy is it? So there's going to be an impersonator account, right? There's going to be a whale who's going to either buy or sell a lot of cryptocurrency to make the market move, right? It's going to give us a scenario where something like that happened in real life, so we can test against it. We're essentially manipulating the market here, so we can see the difference in the buy or sell. This is a sandbox environment, like I mentioned, so we've frozen the blockchain. We can manipulate the markets. All of this is local. It's not affecting the real blockchain. It's not like illegal market manipulation, just for testing purposes here. So this is how it's actually going to look. Let's go back to Visual Studio Code here. Actually, just real quick before we do that, I want to look at Balancer one more time. So we looked at Balancer, this code here. This is the template for the flash loans that we're going to use tonight. You can basically just take this, import it into your own code using your own smart contracts, and you're good to go. You could call your contract whatever you need to inherit flash loan recipient. We're going to see that in the contracts we have here tonight. You need to have a function. You could call this whatever you want, something to make the flash loan. The important part of this function is that it's going to do vault.flashloan. What this does is it calls Balancer. Balancer is then going to communicate with your smart contract. It's going to look for a callback function called receive flash loan. This needs to be in your contract. If it's not there, Balancer won't be able to call your contract. You won't be able to take out a flash loan. So it's super important that you have that in your contract here. So, and a good example of this, let me jump back to the code, lower the terminal a little bit here. We're going to look at this flash loan template here. So this is essentially, directly from the documentation that we looked at here. We're going to look at this contract first before we get into the big one. It's a little bit simpler, right? But once you get this and you got it, the big one is going to make a lot more sense. So this comes directly from the documentation. This is our flash loan template. We are inheriting flash loan, just like it says to in the documentation here. We have a vault address here. Our get flash loan function, the important part of it, it calls vault.flashloan, right? We then get something back from Balancer. It's going to look for the receive flash loan function here. All of this came from the Aave documentation, right? So this is our flash loan template. All it does, super simple, is it just make sure is a contract that's just going to borrow money from Balancer, right? It's going to prove that it got the money and then just give it back, right? That's it. We're not talking to Aave yet. We're not talking to Uniswap yet. This is just the raw flash loan pattern. If you can understand this template, right, you could definitely take this template, bring it to some of your other applications, right? Edit and adapt it into your other projects. I think it's worth going through this real quick. So if we look at the top, we have a few imports here from Balancer. These are what's called interfaces. Interface is going to come up over and over again. So it's basically just a blueprint. It defines what functions a contract has and what their inputs and outputs are. It doesn't include actual code. So when we import the Balancer interface, we're not pulling in Balancer's entire code base. We're just saying like, hey, here's the shape of Balancer. Here's how to talk to it, right? So when you call someone on the phone, you don't need to know how their phone works to call it. You just call it and it's going to respond, right? So that's how Balancer works, as long as you have the proper function and you call it in the right way. So that's our flash loan template. We have flash loan recipient. We're inheriting it. That's promising Balancer that our contract knows how to receive a flash loan. It's like, we're playing by the rules here. So we have two functions, get flash loan and receive flash loan, right? This is the pattern that we're going to see over and over again. Function one, get flash loan here. We have a balance before. So we save our balance before so we can verify it later. We're then going to go ahead and package up the information, right, with ABI encode. So ABI encode is long story short, it's binary serialization, right? Think of it like packing a box, right? So we're packing a box and we're shipping it somewhere to unpack it later. So we're going to go ahead and do that. We're setting up arrays to talk to Balancer. Balancer allows you to flash loan multiple tokens at once, so it expects an array and it's set up. So even though we're only doing one token, we still need to set up an array. So we then call vault.flashloan. Boom. Now the information is in Balancer's court. We now need to wait until we hit receive flash loan. This is the callback. So Balancer is going to call this on your contract after it sends you the money, right? So you're not going to call this yourself. Balancer does. No one else can call this function. It's not going to work, right? We have MSG at sender equals address vault, that vault address that we have here. So it's only going to work for Balancer. This is a security check. You don't want anyone to call this function. So, and imagine someone had like all of the correct data and they were trying to like, because this happens in blockchain. People have all the correct data. They're trying to pretend that they're the Balancer account. If you don't have this check here, it will accept the data and, you know, they could do something malicious. So just a security check. If someone's not the real Balancer, it's not going to work. Right? We slam the door shut on them and then they can't interact with the contract. So, we decode it, right? So we unpack that box that we packaged earlier to Balancer. We have the token, the amount, balance before, and then we do some more checks to make sure that the math works out properly here. We are going to, and then if it doesn't, it's going to revert. So that's the awesome thing about the flash loans. If something's not going to work out, it's going to revert. So, you know, no stress. If there's going to be a mistake, it's just not going to work. The comment right here, notice this, use the money here, right? In a real contract, this is where your strategy is going to live, right? So this is where you would set up your strategies. We're going to see that in the big contract here in a second. But in this template, all we're going to do is just admit that we did a flash loan. So, hey, we got the flash loan. That's it. The last line is the most important of all. We have ERC20 flash loan token transfer address, the vault, the flash amount, plus the fee amounts here. So you're giving the money back, right? So what we're doing here is we're just flash loaning it, giving them, getting some money, and then just giving it back, right? So we do fee amounts 0. So we don't have to calculate it. The less in Solidity is very math intensive, right? Or very gas intensive. You got to be clever with your development. If you could cut out some math, cut out some calculations, that's better for gas consumption, right? So just saying, hey, whatever the fees are, we're going to pay them, right? If you don't have, if you can't pay everything back, the transaction ends, the whole thing reverts, right? So that's the magic of flash loans. If you don't pay it back, it never happens. So this is the template, 2 functions, ask for the money, use the money, give it back. That's the flash loan, right? We have a flash loan test template. And basically all this does is test our 2 functions. Whenever you write smart contracts, you write functions, you want to test that everything works as intended here. So we have a receive for money. We have our setup function here. This is actually relying on that contract. So we come into here, right? We have Chai for testing. We have Hard Hat because this is where we're getting all of our blockchain stuff from. We have some constants defining the constants file and these are just the addresses. We're bringing in what's called a fixture, and I'll get into that in a second here. This test is going to just test that contract to make sure that it works as intended. You should do that. So we're just going to try to flash loan $1,000. We sent the amount. We load the fixture. This is going to go ahead and deploy the contract. So we use ethers to get an owner. We do flash loan.template connect, get flash loan. We do a flash loan. We do await expect. Expect comes from Chai. Basically, what we expect the transaction to do, and with args, what arguments we expect to come out. So we go ahead and do that. Nothing too complicated here. We call get flash loan, right? You see USDC, ethers parse units amount 6. The 6 is for the decimal places. USDC has 6 decimals, unlike ETH, which has 18. And then look at what we're asserting here, right? So we're just saying that after this flash loan happens, this is what we're expecting here. We're not checking for profit because all this flash loan does is borrow money and return it. So we're kind of just looking to see that the event got emitted from the template. This this flash loan here. We're looking for this event. If this event came through, well, then everything worked as intended here. So, and that did happen when we tested our stuff. So the flash loan successfully did transfer the $1,000 as intended. We know that the contract's working. So if we didn't see this, right, this means that the event didn't get emitted, and this kind of would let us know that something happened here in the flow of the logic. So there would have been a mistake. So we you know, that was how we tested for this. The whole loop worked, right? So we borrowed, we did the thing, and paid it back. So that's how that works. Small intro into the testing before we get into it. Now I think we're ready for the bigger file here. This is the main event. Let me lower the terminal here. All right, so let's talk about opening a long and short position first. So this contract that we're going to be looking at, essentially, you are the trader. You're going to send your tokens to the smart contract, and you're going to be able to interact with it on the Uniswap application. So you're going to be able to interact with Uniswap here. We're also going to be able to talk to Aave. All right, so we're going to talk to Aave, and then we're also going to talk to Balancer, all in that contract. So So that contract's going to kind of be like the wizard behind the curtain that's interacting with all these different things. So what's it going to do? Well, step 0. Step 0, right? We're going to send our money to the contract because we want a flash loan, right? So we're doing this with leverage trading. Step 1, we're going to want to request a flash loan from Balancer. Step 2, we're going to get some tokens back here, right? We're then going to take the tokens, jump over to Uniswap, do a quick swap, right? Bring it back to the contract. We're then going to supply our tokens to Aave. Step 4, supply to Aave. Step 5, in the same thing, we're going to borrow from Aave, right? And then before everything is over, we're going to repay the flash loan. So that's the final step here. That's always going to be the final part of the of all these steps. You need to repay the flash loan, otherwise it's not going to work, right? So we can actually go look at that inside of our smart contract here. So all right, so I'm going to go through this code top to bottom here so you understand it. You could definitely pause, rewind the video. At the very top here, lines 1 to 17, these are where we have our imports and interfaces. So at the top, we're importing a bunch of interfaces, just like we saw in the template. Balancer gives us iVault. We literally just talked about this, right? Balancer gives us iVault and iERC20. We also have iFlash recipient because we want to make our contract that so we could do flash loans. We're also using things from Uniswap. So to be able to do all the swaps and everything like that from our contract, we're bringing in the library here. So we have Uniswap with iRouter here. We have some stuff from Aave to talk to the pools to do the lending, and we need to grab some data types to comply with the stuff that Aave's got going on here. So a few of these things should look a little bit familiar because we just went over it. So line 15, custom interface for iWETH. Essentially, all we need to do for ETH is change ETH to WETH, wrapped Ether. So we just have a deposit function here. Super simple. This is how you convert raw ETH into wrapped Ether. Ether itself is not an ERC20 token. Some people don't know that, but just same way Bitcoin, right? Wrapped Bitcoin. So ETH itself isn't an ERC20 token. It cannot be swapped on Uniswap directly. So WETH is the ERC20 compatible token that we're going to be using. It's how you wrap it. So you send ETH in, you get WETH back. It's the same value, right? It's just a format for the rest of DeFi, so it knows how to work with it. Going down, right, we have our contract is iFlash recipient. We're just inheriting it. Lines 21 to 37, we have our constants. So we have our constants here. We have some hard-coded addresses. We got our WETH address, USDC address, the vault address for Balancer, Aave pool addresses here, Uniswap router address. We have a pool fee, right? So Uniswap works on fee tiers. I'm not going to get too deep into that. The fee tier that we're using is of 5%. Uniswap V3 has variable different pool rates, and you have to specify which one you want. The WETH USDC pair that we're doing has a 5%, so it's the most liquid out of all of them. That's why we're using it. So you don't have to worry too much about that, but that's why that's there. We have an Aave. I didn't want to skip over this. Aave health factor threshold. This is just one, right? It says 1E18, but it's just the number one represented in Ethereum because Ethereum has 18 decimal places. So Solidity just needs that. So we use this to check that the position is safe. I'm going to talk a little bit more about that later. We don't need to dive too much into it right now, but that's what that variable's for. All right, cool. So then we have address, public, immutable owner. What's immutable? So immutable means that it's not going to change. It can't change. That's what immutable keyword means. You basically, you set it once and you can't change it. The owner gets set in the constructor and then it's locked forever. So if you don't know, the constructor runs on deployment. So whatever code is inside the constructor on deployment, it's going to run. If you want the contract, any contract to have some state, when it hits the blockchain, this is where you're going to define it. So MSG.sender, that's the person connected to the contract. Whoever is connected to the contract, right? You're going to be the owner as soon as you deploy this contract. So, and then no one can change that. Keep going. All right. So don't want to skip over this. Lines 40 to 52. These are called structs. They are, we have two of them. So these are custom data types, right? These groups are related information. It's better just to put information together like this. We have variables up here, but doing structs is clever development in a way, right? Because we're going to save on gas a little bit here. So it's cleaner than just having all these different arguments. This avoids what Solidity calls a stack too deep error, which is going to happen when you juggle too many variables at once. So open params has 5 fields, really easy to understand: asset to supply, asset to borrow amount, your initial capital, and then the expected swap amount, right? So when you're flash loaning, if we were to do we're going to do this for a long position, right? So what you're going to put in Aave as collateral, that's going to be the asset to supply, right? So that would be WETH, maybe. Asset to borrow, or flash loaning, we're borrowing from Aave. That's going to be USDC. Asset to borrow amount, how much we're going to flash loan, $1,000, $2,000, right? Your initial capital, you started with 1,000, flash loan 2,000. Your expected amount. This is your slippage protection. It tells Uniswap, I'm willing to accept at least this much output from the swap. So if you can't give me that much, reject the whole thing, throw it away. Close your struct, close params. Address, asset to withdraw, asset to repay. Just 2 simple fields here: the collateral to pull out of Aave, right? And then the asset to repay. So it's, you're going to pay your debt off here. We have a modifier, only owner. You're going to see this in functions like open position and close position. Only the owner can access this function. You don't want to have repetitive code in your functions here. So this require statement, it just checks that MSG.sender equals the owner. If the owner tries to run one of these functions, open position, for example, and it's someone else, right? It's going to say position caller is not the owner. You don't want anyone to just run these functions. And instead of writing this require statement like 10 different times in the file, we get to write it once, do what's called a modifier, and put it on our functions. Just cleaner code. It's a security check. You don't want anyone to run these functions, like I said. So scrolling down, open position. This is our main entry point. You, the owner, you're going to call this with your params. The first thing it does is it checks the modifier, right? Are you the owner? Okay, awesome. Then it has a variable here. Is open position true? This is super important. We're going to talk about this in literally a few seconds, but this is the first thing that happens. We have a Boolean. That means true or false. It's true. This is an open position. We then have some params. We encode them, right? We put them in a box. We have some data, and we encode the open position, that Boolean, and the params together. We get ready to request the flash loan, right? Because we need an array. And then we send it off to Balancer. So we do iVault.flashLoan. Balancer is just the messenger here. So we're going to go talk to it. It doesn't care what's in the data. It just cares that it came from you. You're calling iFlashLoan. It's going to call us back. So we set up the token arrays and amounts. Same pattern as the template that we just looked at, right? And now the contract waits for Balancer to call it back. Again, the only owner is a modifier signature. It's that reusable guard. And this is going to run a check before these functions to make sure that you are the owner or it's not going to run. Let's look at close position. Super duper similar, right? If you want to close your position, open position is false, right? Because this is not an open position. It's going to be closed. We pack everything up with ABI and code, put everything in the box. Instead of this was asset to borrow, right? For open position, closed position is going to be asset to repay. A little bit different. Also notice that we're using a get debt function. Okay. Why does this matter, right? So this is a function for Aave. It reads the current debt that you have. So whatever your collateral is, every block that it sits, it's going to occur a little bit of a fee. So that debt is your actual flash loan size that you're going to have to repay. Why does this matter, right? So you want to make sure, again, clever development. If you're doing math for calculations, it's going to cost a little bit more gas. So get the full debt. That's what we're just going to ask for here, because we're going to have to pay it back to Aave anyway. Otherwise, it's not going to work. So get the full debt. We don't want to do any math. The amount you borrowed when you open the position is going to be slightly different from what you owe. So you're going to have to flash loan exact debt. Otherwise, it won't work. We're going to repay Aave, and then the transaction is going to go through. We do iVault.flashLoan, exact same thing. And then, my friends, what happens after we call iVault.flashLoan? We call the receive function, right? So that's what's going to happen in the pattern we talked about in the flash loan template. Anytime you do get flash loan, we're going to be waiting for a callback from Balancer. So now we look at receive flash loan. This is the callback function. First thing it does, really important security check, is the person calling the vault, right? If it's not the vault, throw it out. Where this is not, this could be a malicious person or something like that. We're taking in a few parameters here, the amount, and after the callback, it just does, exactly what the template does. It impacts our user data. So it does a decode. And now this is what I said before, is open position. We have an if statement here. So depending on if the position is open, true or false, right? It's going to do different things. So if it is open, true, it's going to go ahead, open params, right? Decode, going to run an open function. We're going to take a look at that, because it's going to open the position. Otherwise, if it's a close, right, it's not open position, it's a closed position, it's going to run a close function here. So that's what the routing is based off of here. We were able to condense the code, put it all in one function. I mentioned earlier, that's where you would kind of put the logic for when we were going over this. This is where you would use the money here, right? In the flash loan template, this is where you would put your logic. So jumping back to the position.sol. We're going to go over open and close, but that is how open and close position work, right? We have these two functions. They're really similar. One goes one way, one goes the other way. They rely on the same flash loan pattern, receive flash loan, and then they do something different depending on it's open or close. All right, so I think you got that. Let's look at open. So when you open a position, right, the first thing you're going to do is you're going to send your token into the contract. We're going to call Balancer like we just did. So we're at this point. Balancer sends it back. Now it's doing the open. It's going to do a swap for us. So jump back to the code. First thing that happens here, we use stuff from the Uniswap library here. Asset to supply amount, right? We're going to swap the asset to borrow, asset to supply, and then asset to borrow plus our initial capital and the expected amount. In the same transaction here, go back to the graphic. After we swap it, what happens? Back to the contract, go to Aave, right? We supply a token. Supply. Borrow, right? Asset to supply amount, asset to borrow amount, right? So this should be making sense. Super readable here. We do the supply, goes to this. What's the last step? You repay your flash loan, right? So we borrow it. We then look at the health factor here. And, we just want to make sure that right off the bat, we are not getting liquidated, right? So this is important. It's one of the first things that get checks here. We do this, and then we know that we're good. So if the health factor is above, get health factor, right? We do a check. If it's above what we defined, which is 1, everything's fine. If it's not, right, that means that the position could already be under collateralized the moment it opened. You don't want that. It's going to revert the whole thing, throw it all away. This protects you from opening a position and getting immediately liquidated. So we got all of this documentation from the libraries and the websites I showed you before with Aave Balancer and Uniswap. So all of it's right there, super clear in the documentation for you to see. Let us go look at the closed position real quick. So closed position is really similar to open position, and the steps are in opposite order. So, it starts over here, ends over here, right? This one's starting over here and then ending to you. So step 1, right? You request your flash loan, you get your tokens back. You're going to repay the borrow. You're going to withdraw. You swap on Uniswap, repay the flash loan, and then keep whatever the profits are. Okay, right? Let's go look at the close function. So the same thing, like I just said, the steps: we repay, we withdraw, and we swap. Okay, right? Super important. We just go look at it again. Repay, swap, repay the flash loan, and then you keep what's left. Okay. So it's a mirror image of open, essentially. The sequence is very important. If you don't do this in the right order, things obviously will not work out right. So we pay off our debt to Aave, gets our collateral back. If you try to withdraw before repaying, Aave is going to reject it. So we withdraw, we pull it all out of Aave. The withdraw function returns how much came back. Then we swap. We convert the collateral back to the token we owe Balancer, of course, right? So asset to withdraw, asset to repay. And then the flash amount parameter is passed into close, and then we need to get at least enough to repay the flash loan. Otherwise, the operation was a loss, and then everything's going to revert. Going down, we have what are called protocol primitives, right? There's 5 of these functions here that we looked at: swap, withdraw, repay. And these use the libraries above with the protocols that we are using: Balancer, Uniswap, and Aave. So lines 216, almost to the end, 299. We're just going to look at all these real quick, these functions, just so you understand how to use them yourself. But these are the building blocks that we used here, right? Each one very clean, focused function: token in, token out, amount in, amount out. So swap is going to be a Uniswap function here. That's how we swap USDC and WETH. So we're going to approve the tokens, build the exact single input parameter struct, right? That's what's going on right here. iSwap router, that's Uniswap. We have token in, token amount, that pool fee that we talked about. Address this, that's our smart contract. The deadline here, this is going to be blocked at timestamp plus 20. That just basically means the block that we're in plus 20 seconds. Amount in, minimum amount out, right? That's our slippage protection working here. Supply, really easy, asset to supply. All it does is approve it and then supplies it. So Aave deposits it, and your account gets credited with basically Aave tokens. It's like their receipt. So you supply it, they give you something back. It's their Aave token receipt. Then lastly, you get borrow, another Aave function, or it's not the last Aave function. There's one more. We got borrow, calls iPool, right? Using that interface we defined up above, dot borrow. And then it borrows. It has, if I hover over it, I was hoping it would show me the function, but this is a function from the library. This 2 right here, this just says interest rate mode equals 2. It just means a variable rate. You can look at the documentation onto that, but that's the rate we're using here. Address this is our smart contract. We have repay. This approves type UINT 256 max, right? So we do IERC, asset to repay. We approve it. This is going to be the max. So with the maximum possible integer, we're approving it. Basically saying whatever the number is, that's what it is. We're going to call iPool repay right underneath it, asset to repay, and then the max. It basically takes out what you owe, the principal plus accrued interest. So even though we authorize an unlimited amount, they're not going to bill us an unlimited amount. But this is how you avoid having to calculate more math. There is going to be a debt. There's going to be some interest, right? We don't want to sit here and calculate it's going to cost more gas. Just whatever we owe, right? So this gives us the exact balance down to last way. So last function for Aave, we got withdraw. And basically the same exact thing now. When after we repay, we're going to withdraw our collateral. It's got that same pattern of, just give us we're approving the max. Just give us the max of whatever it is. Aave gives back everything you have. You return the amount with the close function, and now basically you know how much you got to swap. At the very bottom of the file, last parts of this file here, we have supply to Aave, right? So lines 309 to the end. Going to go over this really quick. You got to know how to use these functions. These are management functions for handling your position over time. Supply to Aave, right? Lets the owner, says only owner on it, right? Lets the owner add more collateral to an existing position. So if your health factor is getting too close to 1, right? Or you're worried about liquidation, you can top it off basically without closing and reopening a new position. So if you're familiar with leverage trading, this is super common. If you don't want to get liquidated, you could add a little bit more in there. We have some emergency functions, withdraw from Aave. You can exit with your collateral. It sends it directly to the owner. We have withdraw ETH. Same exact thing. You can withdraw your ETH, withdraw your max tokens to the smart contract. This is used from the smart contract. This is useful if you have like some profits sitting here or something. Withdraw tokens. We got get ETH. Only owner function again, right? This just gets you send ETH to it, contacts ETH's contract. This is just how the short position gets funded with ETH for our test. Don't need to worry about too much. Get health factor, important function. That's just how we, make sure that we're above the 1, that we're not getting liquidated or heading towards that territory. Get debt, Aave function. Ask Aave for the reserve data for a given token. It's going to pull the variable data and give us basically like the debt token address. It's going to check the balance of that debt token in the contract. That's your current outstanding loan, including interest. So anytime, just like with the flash loan template, anytime you make a contract, you're going to want to test it. So we have some tests for the contract itself. It's not doing that situation that we saw in the console, but it's actually testing the contract, making sure it works as intended. So this is, we use Foundry to do this. Foundry is awesome for writing tests. It lets you write unit tests super quick because everything's in Solidity. So this is not JavaScript. This is still Solidity. Something different than TypeScript, right? So these are just quick isolated tests. If we go into it, we have receive for money. It looks similar. We have a setup function. Notice here we're importing position. This is the position.sol. We're importing the smart contract into here so we can use it. Sorry about that. So we're importing it in here so we can use it, right? We have owner, so that's going to be the contract, right? We have an attacker. This is good because we want to make sure that a malicious account can't interact with these functions, and we're going to test that here. So we have a fake account. And basically what we're going to do is just every time the test is run, it's going to start off with a clean slate. It's going to run this setup function. So let's go ahead and go through this. We have test owner requires that the position.owner, so it's our position smart contract. The owner is who it thinks it is. Otherwise, owners don't match. We want to test ETH withdraw. So this uses a Foundry cheat code. We're going to see this a few times. vm.deal, vm.prank. We're going to see these things. In a normal blockchain, you can't just give ETH out to people out of thin air, but we're in a test environment, right? In Foundry, VM deal actually gives you the ability to send ETH around. So gives the contract 1 ETH. That allows us to do a test. We do position.withdraw ETH. We're testing that we could pull money out of the contract. We have a little bit of math here that we're saving this to. And then we do a require statement. We're just checking that, hey, was this successful? Is the owner's balance, did it go up? Were they able to withdraw? Is the balance in the contract 0 afterwards? If all of this is yes, then we won't see these error messages. It's all going to go through. And then the contract works as intended, right? Test only owner can open a position, right? We have vm.prank. This is another one of those cheat codes I mentioned to you, right? VM prank basically just says that the next person to run this transaction is going to be this attacker account up here. So we're going to expect this position to revert because they're not the owner. We do expect revert, position caller, not owner. Now, if this doesn't revert and we don't get this error message, this test will be a failure and it won't work. We want this test to pass. So we want to make sure that if the attacker tries to do this, it fails as intended. You always want to test your use cases and failure cases. All right, awesome. So only balancer can close a position, the same exact thing, same really similar function, just making sure that the attacker can't open or close a position. We have balancer is the only one to call this. So again, if you see it's just running the flash loan function, but the person that's trying to do it is the attacker and they're not the vault. So they can't do this. They have the dummy data, right? They have all the data we're expecting, but it's the wrong address. It should revert. We want to test that only the owner can withdraw ETH. That's really important. You don't want anyone to just be able to withdraw. So we got VM prank attacker, right? We gave them 1 ETH. We gave the contract 1 ETH, right? Address position. We're trying to see if someone else can withdraw it. We expect to get this error message. Awesome. Same thing. Caller is not the owner. We expect this to fail as well. So, all right. Oopsie. All right. So let's look at this example here. I'm going to zoom out a little bit. All right. So let's look at an example of like 3x leverage, right? So basically 3x leverage long flow. Let's say you have 1,000 USDC, you flash loan 2,000. You now have 3,000 USDC. You swap it for wrapped Ether, right? You're going to borrow 2,000 from Aave and pay back the flash loan, right? So we've already talked about this. We've taken out a 2,000 USDC flash loan. That's kind of what's going on in our code here. Oopsie, let me minimize it. So that's what's going on here. How we're testing that. We basically swap for Ether right here, and then we're gonna need to supply to Aave. So that's what happens in when we do these functions for open position and close position. Scrolling up to it's very far up. That's basically how we do this, right? So we just call the borrow function. We supply to Aave, get it back, right? Do the swap. We pay the flash loan all in one transaction. Boom, done, right? Then we expect to receive the flash loan function, right? So receive flash loan, whether the position is open or closed, it's going to do 2 different things. And then it's going to, transfer it depending on if you're open position or closed position, what that Boolean is. So. To close it out, right? You would flash loan it back, repay it, withdraw however much ETH was supplied, right? Swap it all back, and then you would pay back the flash loan. So let's talk about the profits scenario for the case of the long, right? ETH goes from 3,000 to 6,000. You make a 3,000 profit instead of 1,000. By doing 3x leverage, it's simple math. ETH goes up 33%, right? You get a 33% movement here, just in case you want to see some other scenarios. If you want to go short, right, go the other way. The same thing, you can have 1 Ether, flash loan 2 Ether, right? Short means you think it's going down. You swap the 3 Ether for USDC. They deposit the 3 Ether worth of USDC back to Aave. You're going to repay the flash loan all in one transaction, right? Some time will pass. Now you want to close the position. You're going to flash loan the 2 Ether, pay back the 2 Ether on Aave, withdraw it all, right? Swap it on Uniswap, pay back that flash loan. And then in this case, maybe ETH's at like 6 grand. It's going to fall to 3K. Just, quick math. You make a quick profit. It's 3x leverage. There's less upside though, because it's of a short. So, why would you want to, do either of these things? Just things to understand the max profit amount and for going long and going short, right? It's unlimited essentially, right? Because the price could keep going up. Doesn't mean it will. For a short, the price can only go down to 0. So that's, that there is some math involved that you could probably do to see what the max is. For a long and for a short, it's basically your collateral. That's what you can lose. So whatever your initial capital is, if you get liquidated, you're going to lose it. You profit for a long when the price goes up. You profit for a short when the price goes down. So shorts are considered riskier, right? But that's how that works. So, all right. Let us look at the JavaScript code here. So there's a few things to understand. We got the impersonator. We're going to have an investor. Where's the fixtures? Right in front of my face. So we're going to have a few things here, right? We're going to have an impersonator. That's going to be like a big whale account. That's the superpower we get with hard hat. We're going to use the position contract that we talked about. We're going to get that impersonator account to send our smart contract some money. It's going to fund us. So if you go look at the position fixture, this is where we're going to be doing our testing. So where's the unlocked account? So we have unlocked account. We get it from a constants file here. That's where the account is hanging out the actual address. I'm not sure whose address it is, but they're certainly a whale with a lot of currency that we can use. We have const impersonator. We do ethers, and we're doing a hard hat thing here. Get impersonator signer. This is the unlocked account. So we're sending ourselves some money here with this unlocked account. This is how we're going to fund the contract. The owner of the contract, that's going to be us in this situation here. And basically what we're going to do is we're going to be able to take like a snapshot here. And this is going to essentially just, we're going to use this for setting up a test, but a fixture is basically just an example, right? And what we're going to do is take a snapshot of the blockchain so we can reset back to this like initial starting point for each test. So let me pull up position.typescript also. We're going to use these two files. We're going to go back and forth here. So the fixture file has 3 functions that stack up on top of each other. We have position fixture. We have long fixture, right? Because we're testing both positions. We're going to test long and and the short fixture. So 3 different types of tests here. Position fixture, that's going to be our base camp. That's where we're going to start off. It's going to take out blockchain snapshot, save the state, right? It's going to deploy a fresh position contract every time. So the way this works is that we get our USDC, our WETH. We're going to have our position contract. We're going to deploy it right here. We're going to get an owner from Ethers, right? This is something from Hard Hat, and the impersonator also from Ethers. We send $8,000 from the whale account to ourselves. That's just going to be gas money for us. So the power of the impersonator. If we go down to the long fixture, this builds on top of position fixture. That's why we're going to grab it right here. So this sets up all of the tests, position fixture, and now we're going to test a long. So initial capital amount, we're going to have 1,000 USD, USDC. That's 6 decimal places because that's just how USDC works. So 1,000 initial capital. We're going to borrow 2,000, right? 3,000 in total. That's our 3x leverage. The impersonator account is going to transfer 1,000 into the contract for us, right? And then we have some open params. And this is what it gets exactly past to the open position in the contract. So asset to supply is going to be WETH, asset to borrow USDC, asset to borrow. We're going to have the borrow amount, initial capital amount, right? And then we have the expected swap amount here. We're using something called quote. This is from Uniswap. Uses Uniswap's quoter, and it basically just says like, hey, if I trade 2,000 USDC for WETH right now at this block, what would I get? And that answer is, that's essentially our slippage floor. We then do position.connect. We're talking to the position contract. We open a position with the owner, right? We send in these open params. We do a .wait. We wait for it to settle. We check the initial health factor, make sure we're not getting liquidated, right? Or right off the bat. We log all of this in the console. And then if everything's good, right, we're going to, we log our the current health factor, and then we do some swapping. This swap is using the impersonator account, right? So this is where we do our market manipulation. The impersonator is sending in 1, 2, 3, 4, 5, 6, 10 million in WETH, right? So that's a huge 10 million USDC, right? So we're doing USDC, 10 million USDC. That's a huge buy order. It swaps it on Uniswap. So this is going to cause a huge, a dramatic shift in the price for WETH. So we're going to log the price before and after. And then we check the health factor again. If everything went great, awesome. A block or two goes by, right? And now we do close position. So then asset to withdraw, it's different. It's in the opposite order, right? Instead of WETH and USDC, it's then WETH and USDC in the opposite order here. We close our position. We use the close params, which is just these two things, right, from the position contract. We wait. We let everything settle. We return, and we get all of this in the console here. We snapshot it, resets the test so we can do the short test, right? So we're going to run these tests again at the very end just so you can see it all. Now it might make more sense, but we do a market manipulation. We do a few swaps. We can test and make sure that the contract's going to work as intended, and it certainly does, right? Awesome. So now we're going to go look at the short. The short is essentially a mirror of the long, but we're doing it short. So we get the position fixture, our initial capital, right? Instead of doing USDC, we're going to do WETH. So we get 1 with 18 decimal places, right? Because ETH has 18 decimal places. The borrow amount, we're going to borrow 2 WETH. We have our open params. We connect with our owner. We get some WETH. That's why we have that function in the contract. We get some initial WETH, and that WETH was funded by the impersonator, right? So we can do this. Initial WETH balance here. We format it. We got our token balance. We log it into the console. We got our open params. Asset to supply, USDC. Asset to borrow is the WETH. We have our borrow amount, our initial capital. We quote Uniswap, right? How much are we going to get at this block at this time? We do open position. So now we're going to open our position here. It's a short. So we check our health factor. Everything's all good. It's going to log everything. Format units. Okay. Does the swap. Swaps WETH for USDC. The impersonator account's going to do this, right? They are swapping 1,500 WETH, 1,500 into Uniswap to buy USDC. This is going to be a massive sell order. So it crashes the WETH price, simulating a bear market. And that's what you would do for a short. So we're betting on the market falling. And now when we close, so we log a few more things here before and after. We have our close params, asset to withdraw, asset to repay. We then do the close position, which is in this contract, right? It's in position.sol. We do close position now. We do close position, and then we wait for everything to settle out. We return this. Everything's logged into the console. Everything works as intended. Awesome. So these are our fixtures. They're testing, these long and short scenarios here, right? And then we have position.typescript here. So this is actually where we test our assertions to make sure that things are expected. So position.fixture, we have scenarios. So position.fixture, long fixture, short fixture. We have a long and short. And now we can test the end result is what we expect in here, right? So we could see that this stuff happens, but we want to make sure it happens as intended. So we have 3 test groups here. we have a long position, we have a short position, and we have withdrawing. These are the three things that we want to test. We want to test that our contract can do a long, a short, and we want to be able to withdraw. So describe this is just coming out of chide. That means you're describing what you want to test. We're testing our position. Inside of the describe, right? We have 3 individual describes because we're testing the long, the short. It is actually how you write your test. So what are we testing? We're testing that it is an open position, right? We get our position contract, our snapshot, our initial capital amount. We have our network helpers, which is the load fixtures. So we're getting our long fixture because that's what we want to test. We're testing the long. We check our final token balances. So this is after that scenario played out the long. We want to make sure that the Aave WETH balance is 0. We want to make sure the WETH balance is 0. The USDC balance is 0, right? Not ours, but on Aave, right? Everything's gone out of Aave. We paid back everything. And that we expect that the end of the position, we expect that the USDC balance is greater than the initial capital amount, right? So all of this gets logged. We make sure that all of the balances are what we expect. It does snapshot restore, basically rewinds us back, rolls the chain back so we could do the next test. So we log all of this into the console so we could see it. Let's go look at short. It's extremely similar. The short position does the same thing, but flipped. We grab our position contract, our initial capital, our snapshot. We have load fixture, and we are pulling in the short example, right? So by the end, when the short happens, we want to make sure that our balance on Aave is 0. Our WETH balance, this is the difference, right? We're checking that the WETH balance is greater than the initial amount. We want to make sure that this was profitable when that market event happened. We check that the balance on Aave is 0 and that the USDC balance is 0 because we're walking away with WETH now, right? We log all of this into the console, snapshot restore, rolls us back so we can do our final test. The last test, withdraw, really simple because all it's doing is withdrawing. So what we do is we grab our position, our owner, the WETH, the snapshot, of course, and then we get that position fixture. We have our initial amount, which is the 1 ETH, right? And we're basically just doing the get WETH function to just send something into the account. We're testing the withdraw. We're not really testing like for profit here. We're just testing that we withdraw. We get our token balance. And now what we expect here is that the initial WETH balance is going to equal the initial capital amount. We want to make sure that when we withdraw, it worked. We do get our token balance after we hit withdraw tokens, right? Sorry, I'm talking real quick. We do withdraw tokens, right? We withdraw. And then we check the contract to make sure that all the tokens are out. Then we do a final check. Is the owner's WETH balance greater than the initial? It should be because we supplied an ETH and withdrew it. So really simple test, super readable. And we just want to make sure if any ETH gets stuck in the contract, we can withdraw it, right? So awesome, right? So I hope that all makes sense. That is an overview of the code for doing the leverage trade with Uniswap, right, and Aave and Balancer. So what we showed you is with a 3x leverage, right? So I'm just going to go ahead and just run the test one more time just so we can see these numbers. And, you know, they should make a little bit more sense now of what happened. We should take a look at it one more time, right? We test that the flash loan contract works. We do a long position. We have initial capital going long, right? This would have made like $300 within that one block time, right? The short position, current health factor is good. Would you walk away with price after? And then you walk away with an extra 0.12 ETH, right? So you start off with no ETH and then you walk away with 1.2 ETH. Pretty good deal, right? So you test both open and closed positions. You test the withdraw, opens a position, allows owner to withdraw tokens. Phenomenal, right? So awesome job, guys, right? So if you made it with me this far, give yourselves a pat on the back here. You know, this is an overview of doing the code with leverage trading using Aave, Uniswap, right? Balancer for our flash loans. And what we did is, you know, we talked about 3x leverage, 2x leverage. I'm going to be winding down here in a minute. So if anyone's got questions, go ahead and drop them in the chat. I'll go over those questions here in a minute, but I'm just going to keep explaining a few things as you guys write your questions. So again, you could kind of do this for high frequency trading. Basically what we talked about tonight, You could put them into your own bots and stuff like that, right? I would, right? Take this code, talk to it with AI, get a good understanding of it before you mess around with it, because this is serious stuff, right? This is real development. So get a good understanding of it. Incorporate into your apps. I know a lot of people from the mentorship are going to be really excited to go down this rabbit hole and try to do some stuff like that. You could do it with your own scripts if you want to. Run it against the mainnet yourself. You could do some swing trading. If you want to use this code on the mainnet, again, it's not audited. So you're running leverage. That's also some risk to your own funds. So you assume all risk, right? But that's how you could do that, right? Is make them scripts run periodically on your computer. Maybe you're savvy, you set up an MCP server with Claude. Claude's set up with X402 payments. It's constantly scanning the web, right, for market things to happen. So yes, and the last thing is that you could play with the leverage amounts. So if you don't like the idea of ETH going down, like 20%, you could do, you don't want to do 3x, you could do like 2x leverage, you could do 20%, right? 1.5 leverage, 2x leverage. It would have to drop maybe like 50% or a little less than 50%. So the maximum amount of leverage that you could probably get away with is 4 times leverage, right? So, and just take a quick look at Aave real quick. Aave has its liquidation thresholds listed. I think Ethereum has like one of the, so 83%. Ethereum's like one of the best ones. So yeah, guys, go ahead and drop your questions in the chat here. I'll try to answer some of them. And again, if you want to code something like this step by step, right? Customize your own strategies. I wish we had the time to code this all out from scratch, but you could. We're already an hour and a half in, my friends, and this was just explaining the code. So unfortunately, we don't have the time for a class like that. But if you did want to code something from the ground up, start implementing your own strategies. Of course, you're going to need more developer skills to do that. So the absolute best way to get those skills is with hands-on mentorship. Okay, we got a couple people in the blockchain mentorship here in the chat tonight that can attest to that for sure. Few people just graduated, so we certainly have a few slots here open. Definitely a great way to take advantage of the current market, right? Head down education. So go ahead and drop your questions here in the chat. Yes, you could definitely use $100 instead of $1,000. You could use $10, right? If I was right, you felt ready to take this to the main net. What I've seen other students do is do like $5, right? And they did like 3 weeks to a month of testing with like once a week, maybe like doing like a $5 trade or something like that. You barely make any profit, right? But it's not about that. You're trying to test and make sure that things are working as expected. So you don't want to go in with $300, lose it all, and then get upset, right? So I would always test with a super small amount of money when you're ready to bring this into production. Scenario for liquidation. Whenever you get close to the threshold, you can always check with those functions, but all of these, they have their thresholds listed on here. 78%. So you always want to be careful here, but I would check these things out here. Maybe there's a token you're really interested in. Definitely, you could just go on here and check, make sure you're not going to get liquidated here. You can't do this cross chain, right? You could do it multi-chain though, right? So you could do it on different chains other than Ethereum, as long as those markets are supported, right? So you're going to have to, if you wanted to tweak that to do it on a different chain, you would have to sub out some of those addresses, make sure you're using the proper addresses for Uniswap, Aave, and Bouncer across other chains. They're EVM compatible, but they will have different addresses. So, do your due diligence and research. There's probably other trading platforms you can use for this. All right, everybody. Well, I guess we'll go ahead and wrap it up there for today. It's been a great session. I'm super excited to show you guys how to code with Flash Loans, how to do some leverage trading, how you can apply this to your own trading bots, your own trading scripts, whatever you guys want. Again, so I'll put a link in the description below if you guys are interested in working with the DAP University team and Gregory and I become a professional blockchain developer. We will work with you to become a professional blockchain developer, help you break into the industry, land your first job. We'll work with you until you get hired, right? So if that's something you're interested in, is linked down in the description. That's all I got for today. Thanks for watching, everybody, and until next time. See you guys.